All right, listening up. So, the annuity formula, you understand what an annuity is. It's an account where you make regular contributions into, and interest builds it up as well. So like superannuation, every time you get paid, every dollar percentage gets taken out, and that builds up your super account, which then you take out when you're 65. But taking the future value of an annuity, doing it by hand, can make all sorts of mistakes. You might forget to add on the amount, you might do it at the wrong time, you might find out the interest first when you're meant to do it after, and so it causes lots of problems. So the formula helps us to do this. The formula assumes, though, and this is important, the formula assumes that payments are made at the end of each time period. Okay, so it's at the end of the time period that's done, rather than at the beginning. Okay, so remember last lesson we were talking a little bit about the difference between end of the period and the start of the period. Okay, it was a subtle difference, and over a number of years, there will be a big difference in how much money you get. So the annuity formula says that you're inputting the amount at the end of each year. Okay, so if it's yearly, it's at the end of each year. Monthly, it's the end of each month. Daily, it's the end of each month. Which basically means that that interest for that year hasn't been added on top of that amount you put in for that year. Okay? So the formula is A equals the future value equals M, which is the regular repayment, brackets 1 plus R to the power of N minus 1 all over R. And R is the rate as a decimal for that period. Okay, so whether it's a year or a month, R is the rate and N is the number of periods that you're covering. So whether it's 20 years, N would be 20. It's 18 months, and 18 you find the monthly rate. Okay, so that is the formula. You are given this in your formula sheet. However, can I just say that there's no point having a formula sheet if you do not know how to use the things that you get. Alright. From here, there it is. Future value, and then there's a present value. Anyway, we can talk about that later. So, any questions about it? Do you understand what M is? Do you understand what R is? Do you understand what N is? No. Alright. Yes, so M. No, this is not about borrowing, this is about investment. That M is the amount that you put in regularly. So if I say couple $400 a year, that's M. At the end of each year, I'm putting $400. Or that's the amount you put in. The payment you'll make. This is not loan repayment or anything, this is an investment. Right. We can use this for loans, but we're going to come to that later. For the moment, all we're interested in is the fact that this is telling us that M is the amount of money you put into your annuity account at the end of each period. At the end of each year, end of each month. Okay? So, copy that down. Here. I'll do the first example with the formula showing there. So, example, Michael has an annuity that he takes $2,000 per year at a rate of 7% per annum. Okay, 7% per annum, $2,000 a year. So we can work out its future value after 30 years. A equals M in this case is $2,000. That's how much it puts in at the end of each year. So it's 2,000 times 1 plus the rate as a decimal, which is 0.07, to the power of the number of years, which is 30, minus 1 over the rate, which is 0.07. Now, an extra thing you have to be mindful of with this formula is that it's easy to make an error with your calculator. Make sure you put plenty of brackets. I would suggest you put brackets around, not when you're writing it, but put brackets around when you're working it out, the top and the bottom, so that it's clear. So let's see if we can find what the value is after 30 years. I would suggest you do. Oh no, there's only one shape of bracket. That's fine. What did you get? I got 188,921. Which is actually correct. Yeah, so I'm just saying add in an extra. Did you get it? Can everyone do this, please? Yeah. And just use the same brackets as the calculator. Yeah, 188,921. $188,921. Didn't get this answer, you need to figure out where you went wrong and find it. Right? Did you get it? Alright. Now the next thing is okay. So let's give it another go. I'll just move it up to the second one. So the second question says, would she have more or less money in the account if she invested the $2,000 per year for 25 years at 7.8%? So you've got to work it out again and see if you get more or less. So A equals 2,000 times 1 plus 0.078 to the power of 25 minus 1 over 0.078. That is equal to oh, whoops. Yeah, so it's 142,000. All right. So obviously, would he have more or less money in the account if he invested for 25 years? Well, this would be less. So the conclusion is it's less. All right, so you actually have to answer the question. Not just do the working out, that's not enough. You haven't actually answered the question. You then have to make the sentence saying, Michael have less money investing this way. Okay? So that's two examples. That's basically it.